For today's lesson, we're going to be talking about literal equations. So, a literal equation basically is used in situations where you may have a formula or something where you're not actually solving for an unknown value, but you simply want to rearrange an equation that you may have. So, to solve for a literal equation, it means you're going to actually isolate whatever variable that they're asking you for. So let's say I have y equals mx plus b. They may ask you to solve for x or they may ask you to solve for b, and that basically means that you're going to get that variable by itself. So 3 steps to kind of think about it when you're doing these problems. The first thing that you're going to do is you're going to locate the variable that they're asking you to isolate. So after you locate the variable, that's when you're going to use your order of operations, but you're going to use order of operations in reverse. So you're going to use GIMDOS, which is what we've talked about, and you're going to use that in reverse. All right, so after you use that in reverse, then the next thing you're going to do is you're actually going to isolate that variable. You're going to move the stuff around so that that variable is by itself. Now, one thing I always like to ask students to do, which I've asked you to do previously, is I like you to, when they tell you which variable you're going to solve for, circle it, highlight it, whatever you want to do to kind of help you. But in this situation, if I'm looking at number 1, so I have D equals R times E. So they're asking us to solve for R. So since I'm solving for R, I like to highlight it, and that reminds me which one I'm trying to get by itself. So right now, I have R times T. So if I want to move the T over, because that's what's going to get the R by itself, R times T, we're going to do the inverse, which is dividing by T. So I'm going to go ahead and divide by T on both sides. Now, what that does is that helps me eliminate the T on the right side. So now R equals D divided by T. So basically, if I think about this in a scenario, it's kind of like if you want to rearrange your bedroom. You're going to take the furniture and the stuff out of your bedroom and you're going to put that same stuff back in. You're just going to rearrange it. So that's the same thing that happens with a literal equation. You're going to have the same variables or the same pieces left. You're just rearranging it. So I now have R by itself, so R equals D over T. All right, so for number 2, they're asking us to solve for H. So I have V equals L times W times H. So these are all being multiplied. So since they're all being multiplied, I'm going to do the inverse of that, which is going to be division. And I do not have to do these individually. I can go ahead and do the division for both of them at the same time. So get rid of the L's, get rid of the W. So I now have H left by itself. I've isolated it. And that's going to be V over L divided by W. All right, so for number 3, they're asking me to solve for A. So if I'm solving for A, that means that I need to get rid of this plus B and plus C in order to get it by itself. So in this situation, I have addition. So the opposite of addition is going to be subtraction. So I have my B's gone. So right now I have A plus C equals P minus B. Now, my A value is still not by itself. I still have that plus C there. So I'm going to go ahead and subtract the C over as well. Now, remember, these are not like terms, so we're not going to be able to combine those because we're just talking about variables here. So A equals P minus B minus C. And they may put it in word format. So number 4 says the quotient. So remember, the quotient means that we're going to divide there. So we're going to divide. Of a circle's circumference C is the diameter, its diameter is pi. So it's asking for the equation. So they're asking us to write this out. So it says the quotient of a circle's circumference and the diameter. So quotient means division. So we're going to do the circle divided by the diameter is pi. and they're asking us to solve for c here. So if I have c divided by d equals pi, and they're asking us to solve for c is being divided by d. So the opposite of division is going to be multiplication. So this is going to get rid of that d divided by d that we multiplied. So c equals pi times d. All right, so if we step this up just a little bit, we also have equations that we can solve for more than one, with more than one step. So the next one we're going to look at is they want to solve for b. So I have a couple of things happening here. I have b's being multiplied by h and being divided by 2. So we're going to have to use that opposite order. So if I think about my order of operations and I think about GEMDAS, we're going to be working backwards, okay? Now, when I'm looking at this problem, I cannot do anything with the numerator until I get that 2 out of the denominator. So I'm going to multiply by 2 first, okay? So once I multiply by 2, that's going to give me 2a equals, and then I have b times h. Now, I still have not isolated that b value that we're trying to solve for. So I have b times h. So I'm going to do the inverse of that, and I'm going to divide by h. So I now have b equals 2a over h. So again, we're just reordering these equations and we're rearranging them. We're just rearranging them in a mathematical way. We have to follow those inverse operations. All right, number 6. Number 6 is asking me to find the value for w. So they asked me to solve for w. Now, this one's a little bit different because we have right here, the w is being multiplied by 2, but it's being added to the 2L. So we need to move that entire 2L before we can do anything with the 2 because we need to do our adding and subtracting first. So I have a positive 2L. I'm going to subtract 2L. So that leaves me with 2W equals P minus 2L. And again, we're still solving for W here. So since we're still solving for W, we now have 2 times W. So we're going to do division. And when we divide, we make sure we divide by the whole left side. So W equals P minus 2L divided by 2. All right, so for number 7 is asking me to solve for y. Now this particular problem is going to be the most important style of problem. Yes, it still has numbers, but in order to solve for these, when we get to linear equations, these are the ones that we're really going to be solving for and rearranging. So we're going to start with talking about these now, and then we'll talk about how to simplify them later. So if I'm solving for y, my y is being multiplied by -4, and then I have 3x is being added to that. So I need to move that entire 3x over. So I'm going to subtract that 3x over. And by doing that, I'm left with -4y. Now, you do not have to do it in this order. However, I do recommend to help you later on down the road to go ahead and put your variable first. If you put that variable of -3x first, when you get to the linear problems down the road, it'll be a lot easier for you. All right, so I have y, -4y. So in order to get rid of that -4 times y, we're going to divide by -4. And once I divide by that -4, I'm going to divide by the whole right side, and y equals -3x plus 12 divided by -4. And again, there is a way to simplify this, but for right now, as long as you can do this part, we'll work on simplifying when we get to linear. All right, so let's talk about a few word problems here. So it says twice the value of x minus triple the value of y is a total value of 8. So if I write this equation, so twice the value of x, so twice of x minus triple the value of y, so triple is going to be 3 of y, gives you a result of 8. So we have twice the value of x minus triple the value of y gives me a result of 8. So they want us to solve for y. So that's what we're going to solve for here. So if I'm solving for y, remember that means we're getting y by itself. We want to isolate it. Okay. So again, I can't do anything with the -3 yet, but I can go ahead and move that 2x, that entire 2x to the other side. Okay. And in order to do that, I'm going to subtract 2x to the other side. And again, like I said in the last problem, you are not expected to do this, but it is going to help you out later on if you go ahead and put that variable that you subtracted over first. All right, so again, we're solving for y. So I have -3 times y. So the opposite of times is going to be division. So I now have y equals -2x plus 8 divided by -3. All right, in the next one, when we are looking at it, we have the area A of a circle is calculated by multiplying pi and the radius squared. So that is a very key word there, is the area of a circle is, so equals, and it's multiplying pi and the radius squared. So area is pi times the radius and squared, which means it's going to have an exponent of 2. Now, when we talk about this problem, this may be the first time that you're dealing with the opposite of how you deal with the opposite of an exponent. But the problem is asking us to solve for r. Now, the one thing that I noticed is that r is being squared, so we're going to have to get rid of that squared in the end. Before we can do that, though, we need to get rid of the pi. It's pi times r. So in order to get rid of pi times r, we're going to go ahead and divide by pi. So I have a divided by pi equals r squared. All right, so again, we're trying to solve for r. R is not isolated, it's not by itself. So this is how you get rid of a exponent. So no matter what exponent you could have squared, you could have cubed, you could have raised to the fourth, you're going to take the root of that number. So the root of a square root the squared is to take a square root. If I have a 3, then I would take the cube root. If I have a 4, I would take the fourth root. So for this particular problem, we're going to take the square root of both sides. So once I take the square root of a square, that is going to eliminate each other. So we're going to have r equals, and we're left with the square root of a divided by pi. All right, so this one says solve for x. Now, this one I'm going to give you a recommendation on in order to solve for this, because most of you are going to want to distribute. So if I distribute here, that's going to give me x plus xy. But now what we've done is we've created 2 x's that we now have to try to get by itself, and that's not going to help us. That's just going to wind up having to go backwards and undo what we multiplied. So instead of multiplying that out, we can actually go ahead and inverse based off the fact that x is being multiplied by the entire parentheses. So since x is being multiplied by this entire parentheses, I can actually inverse the entire parentheses. So if it's x times the parentheses, I can go ahead and divide by the entire parentheses, just like I would any other multiplication problem. All right, so that gets rid of the whole parentheses, and I'm now left with x equals z over 1 plus y. So whenever you have a problem like that where you're trying to solve for a value, you can actually go ahead and divide by what's in front of the parentheses or the parentheses itself, because it's still multiplication, and the opposite of multiplication is division. All right, so for this one, we're solving for r. Now, this one's a little bit of a special case as well. The reason being is because r is in the denominator. I can't solve for r in the denominator until r is out of the denominator. So in order to get r out of the denominator, I have to do my inverse operation. So I'm going to multiply by r to get it out of the denominator. And that's going to give me I times r, or r times I, it doesn't really matter, equals v. And now we can finish solving for r. So I have I times r, and the opposite of multiplication is division. So what happens is you basically multiply the r over and then divide by what was with it. So this becomes r equals v divided by I. All right, so for this one has a fraction in it that we need to deal with. And I'm going to show you the easiest way to deal with a fraction so that you don't have to worry about multiplying a fraction into your problem. So I'm not sure how many of you remember what a reciprocal is, but a reciprocal is if I have the fraction a over b, the reciprocal is when you flip it and make it b over a. So we're going to use that concept of a reciprocal in order to get rid of this fraction right here, this 5 over 9. So how do I do that? Well, I'm going to take that 5 over 9 and I'm going to multiply it on both sides, but instead of 5 over 9, I'm going to multiply it as 9 over 5. So I'm going to do 9 over 5 on this side, and then 9 over 5 on this side as well. So we're multiplying it, but technically the reciprocal is the division part of it. We're just using it as the flip fraction. So why does that work? Well, I have a 9 in the numerator and 9 in the denominator. Those cross out. I have a 5 in the numerator and a 5 in the denominator. Those cross out. So since they cross out, those are no longer there, and it just leaves me with 9 over 5c equals, and now that f minus 32 is outside of the parentheses. There's no longer a parentheses there because the fraction isn't there. And again, we're solving for f, so that's the reason we want to get that parentheses gone. So now to finish it, we need to get rid of that minus 32 because f needs to be by itself. So to get rid of minus 32, we're going to add 32. And these are not like terms, so you can't add 9 over 5 and 32 because 9 over 5 is with a variable. They're not like terms. So f equals 9 over 5c plus 32. So the key is the reciprocal. Okay. I hope this helps. Wait, one more. Sorry. All right, so then we have a literal word problem for this one. It says 3 less than. Now remember when you talked about less than means that you're going to subtract it from whatever it's describing. So less than means that we're going to do the sum of A, twice the sum of A and B, and then you're going to less 3 behind it, okay? So it says twice the sum of A and B. So twice, I have to multiply twice by A and B. And we're going to have to put that in parentheses. That's the only way that we can multiply 2 times A and B. And we're going to subtract 3 from that because it's 3 less than, and that is going to equal 7. So for this particular problem, they want us to solve for B. So I have 2 times A plus B minus 3 equals 7. Now in this particular problem, we're really going to have to focus on our order of operations backwards. So I'm going to start with my adding and subtracting because I need to get rid of that minus 3 first, especially if we're solving for B and B is in that parentheses. So I'm going to add 3 first. So I have 2A plus B, and I can go ahead and add those because they're like terms. That equals 10. Now, I need to use the B, and because this whole parentheses right here is being multiplied by 2, I can actually go ahead and inverse that 2 with division. So I can divide the problem by 2 in order to get rid of it without having to distribute. So I have A plus B equals, and we can simplify that as 5. So remember, we're solving for B. So this last step, I have A plus B, so we're going to subtract A. And I now have B equals 5 minus A. Or you could write it as B equals negative A plus 5. Either way is correct.